we're reviewing a problem of similar triangles, and we're supposed to solve for X. This comes out of, is that packet 3? Okay, packet 3. And number 5. So if they are similar, that means that the ratio between the corresponding sides is going to be exactly the same. So we can set up a proportion. Now, the first thing we have to do is make sure that we know which sides correspond with which sides. So I'm thinking that the short side and the short side correspond with each other, yes?
Mm-hmm.
Okay, now, whenever I set up a proportion between similar figures, we set up our first ratio or fraction with the things that we know. See, this is X. We don't know all of that, but we know the 10 and we know the 35. So you could set it up either 35 over 10 or 10 over 35. It does not matter which way you go. I always end up going left to right unless they tell me differently. And so I'm going to say 35 over 10, which actually is our scale factor. We found that out yesterday. That's our scale factor if we simplified 35 over 10. Okay, this is the start of our proportion because those are corresponding sides and they're the numbers that we know. Okay, now we have to finish our proportion in the same pattern. So if we went from the big triangle to the small triangle, then I have to put the information from the big triangle still on top. I have to follow this pattern. Whatever I set up here has to be followed here. Now I have to find some more corresponding sides. If they put some information here and here, the corresponding sides that I would pick are the ones with the X in it. That's what I want to find out. And so I want, since this has the X in it, then I want to find the corresponding side in this triangle. And in this case, it's 49, right? Okay, 49 is the big triangle, so I'm going to put 49 on top. And that corresponds on the small triangle of negative X plus 7. Now, we found out earlier on that if there's more than one thing with a plus or minus in here, it's all one set. And so we found out it's much easier if we put that in parentheses. Now, this is definitely a proportion because it's one fraction equal to one fraction. And we know how to solve those now. We know that we can multiply this way and multiply this way, and the products will be equal to each other. So when I take 49 times 10, I get 490 equals. Now this way, I want to take 35 times the set. Do you see? So when I solve this, I've got to take care of the parentheses first. So since I can't add anything in here, I don't know what X is, I'm going to use the distributive property where I multiply 35 times negative 1. Remember, there's a 1 hiding in here, and 35 times 7. So now I have 490. If y'all have a calculator, I don't have mine out. Go ahead and do 35 times 7 for me. So 35 times negative 1, 35 times negative 1 is negative 35 X, because the negative 1 is with the X. Then plus, and it should
245.
be about 245, is it?
Yes.
245. Okay, and if we're solving for X, this is old news now. If we're solving for X, we need to subtract 245 here and subtract 245. I started a little low, didn't I? So 5, so I have 245, yeah. 245 equals negative 35 X. Okay, and because this is zeroed out, I was kind of thinking ahead. Okay, I'm going to divide by negative 35. Somebody please do that. Let's see. What is it? I need 245 divided by negative 35.
Negative 7.
Negative 7?
Yes.
Okay, let me come up here. So when we divided this out, we came out with X equals negative 7. Okay, Well, that's kind of weird because we're talking about the length of a side. But if you look at it closer, in here, x is -7, right? But that's x. Yeah. Can you all see it? And there's a negative on the x. So -7 becomes a positive. And so we have 7 plus 7. So the length here is 14 feet. Does that help, Sherry?
Yes, ma'am. Yes, ma'am.
Okay, any questions on it, or you just want to look at it a little bit more?
The scale factor, I thought that the sides had to be the same number that was the scale factor. It's not.
It is. So now the scale factor, what did I just do? Okay. So if the scale factor here was 35/10, okay, and if we simplify that by 5, it's really 7:2 is our scale factor, okay? Are you with me there? 35/10.
Okay.
And then I divided that by 5 and divided by 5, so I have the simplified scale factor. So let's check and see if we got this correct. 49/14. 49/14 would be here, 49 to what we got here, 14. If we divide both of these by 7, we'll have 7:2. So they do have the same scale factor.
Okay.
7:2. I'm glad you're asking questions. It really helps. Okay, let's go back to the scale factor for perimeter. And I was going to do number 4. I'm on this page, and I'm going to do number 4, okay? Let's try to draw. This is R. And this is S. Okay, and they tell us that the scale factor of, and this is important, S to R. If they had R to S, it would be different. They said it is 6 to 7. 6 to 7. Now down here at the bottom, what they give us is P for perimeter. They don't know this one. That's what we're going to find is X. The perimeter of this one is 24. So we don't even need to know the sides. We know that they are in a ratio or a scale factor of 6 to 7. S to R, 6 to 7. You see, this is the bigger one, smaller one, 6 to 7, S to R. So what we need to do in order to find the perimeter, they're given one perimeter, not this one, but what did they give us that we know for sure?
6, 7.
We know the scale factor or the ratio. That's exactly right. So we're going to use the scale factor to start our proportion. Now, when you do this, you've got to be so careful about which one we're going to put first. We put the S information first, then the R. So I have to put the S information again on top. The S information for the perimeter is 24. And the R information is the one that we're trying to find. So it's an X. Okay. And now we have our proportion and we know how to solve proportions. So we multiply here, multiply here, and we get 6x is going to be exactly the same as 148. Is that correct? Maybe not. 28 to, no, it's 168. 168, yeah. Okay, because I took 7 times 24 and got 168. We're going to solve for the x. So that means we have to divide by 6, divide by 6. So now we have x equals, and it's going to go in 2 times 28.
Yes, ma'am.
Is that correct?
Yes.
Yes. Okay. And so we go back to our picture and we say, what the heck is x? You know, we did all of our work and we're pretty sure we have the right answer, but what is x? Well, you come back over to your picture. It's the perimeter of R. Okay? 28. And if it said feet or inches, that's what you would do. Now, I like also math students need to look at their answers and see if they even make sense. If you made a mistake and you said this perimeter is 12, okay? You came out with 12 and you looked at this, put it here. Does this even make sense? Because the big one has the bigger scale factor. This is big, but you have 12 and 24. Does that even make sense? And so after you get your answers and you did fine, you got your answer, then just glance at it. Is this bigger than this? Then probably it's right, okay? If everything fits, but be sure and be one of those math students that is aware if an answer doesn't make sense, all right? Okay. Any questions on that one? I'm not hearing. Speak now or forever hold your peace. All right, now I'm going to the next page, which is page 2 in packet 4. If you number these, I think I will do, yeah, let's do one with decimals in it. Let's do number 4. Okay, we're going to do this number 4. Okay. Now on this page, they don't give you the scale factor. You're going to have to figure it out yourself. So since you're figuring it out yourself, then you can decide what order you want to put the scale factor in. You can't do anything with similar diagrams until you figure out the scale factor. Okay, we'll find that. Okay, we're looking at this. Okay, and this is 1 yard. That's 1 yard. This is V, figure V. And this is 3 yards. And this is figure U. Okay, it says the perimeter. Remember, the definition of perimeter means I take whatever this side is, add, and add. The perimeter is the distance around the outside. So the perimeter of this one is 15.3 yards. And we don't know this one. We'll use X. They use a question mark. Okay, the first thing you're going to decide is, are you going from V to U or U to V? Doesn't matter to me. Because they didn't give us a scale factor this time. We have to figure it out ourselves. Start with U. Start with U? Okay, we're going to go U to V. Okay, so what is a corresponding side? And they made it pretty easy for you. A corresponding side that you know both of the numbers. The 1 and the 3, right? Okay, which one goes with U? The 3. The 3. And then the U is 1. So this is the scale factor because you found corresponding sides that you know the measurements of, okay? So they want us to do a comparison. They told us these are similar. So what we're going to do is set up a proportion, first of all, with what we know. The scale factor is what we know. and you wanted to go U to V. So I've got 3 to 1 is what I do know. Now this is U, don't get mixed up. So what do we not know?
What?
The perimeter, right? Okay, so what is the perimeter of U? I want to put that on top.
15.3 yards.
And the perimeter of V, I want to put that on the bottom. I don't know it, okay? So I'm going to solve this proportion right here. And so I have 3x equals 15.3. I divide by 3 and divide by 3. So I'm going to come out with x equals 5.1 yards. And what is x again?
X is 5.1
Right, but what is it? Ballerina slippers?
yards.
It's yards for what?
Perimeter.
Of what?
Of V.
You've got to be specific.
V.
Okay, so x, what we found was the perimeter of figure V.
5.1 V yards.
So we have perimeter equals 5.1 yards. So the first page in this packet gave you the scale factor, and the second one you had to find the scale factor, but both of them were done the same way. Okay, kind of? Okay, take a big deep breath. We're switching over to the next set. It's not hard, I just need you to listen. I need you to be focused. Okay, this was how to set up a proportion between the, just had a brain fart, just a minute. How to set up the proportion between perimeter, okay? Now, I need to remind you of something. Some of you weren't in the class, some of you were. Doesn't hurt to remind. Okay, so when we talked about geometry in the last session that I taught, perimeter, heavens, it's like it's a Monday. Perimeter is just to the first power. Whatever your answer is just one dimensional. It's to the first power, and we never write it. It's just an understood one up here. Okay, which means I can go number to number, number to number, number to number, because perimeter is just one dimensional. It's just a line, just a measurement. Then in geometry, we moved to area. And when we did, we found out that all of our answers are going to have a squared on it, because when we find area, it's two-dimensional. Two-dimensional. Now this 2 is what's going to be important for you right here. And I will go on one more step and say that when we find volume, it's 3-dimensional. And so our answers were to the third power, okay, because they're 3-dimensional. This is important to remember, okay? So, love the drawing. I'll make the other one kind of look like it. There we go. How's that?
Yeah.
Okay, now let's say that this is 4 inches or whatever, and this is 2, and this is 3, and that won't work. This is 4 and 2 is 6 and 3. Okay, all right. Now, the scale factor between these two, this is A and B. So the scale factor between these two is 4 to 2, right? Scale factor from A to B is 4 to 2, which is actually 2 to 1. Because I just simplified that. Are we okay with that? Okay. So if I end up wanting to find the other sides, which are just straight lines, then I do what we've always done. But if they give me the area of one, look at this. This is 24 because the area of a rectangle, let's assume that's a rectangle, okay? It's an ugly rectangle, but it still is. Area equals length times width. So length times width is 24, right? Okay, if I find the area here, then it's 3 times 2 is 6. Do you see? So let me see if I'm making myself clear. So the scale factor of the areas are not 2 to 1, they're 2 squared to 1 squared because it's area. When we're comparing just a side or just perimeter, that's one dimensional. But if I'm comparing areas, that's 2 dimensional, which means I have to take my 1 dimensional scale factor and I need to square them. Okay, if you got the foundational information in your head for just a second, let's actually do a problem, okay? Now this, we only square it when we're comparing the actual areas, when they give us an area here and we want an area here. If they just want to compare a side with a side, that's just 1 dimensional and we do it like perimeters. Everybody sort of okay? Hanging on by a thread, are you? Let's
So can
go
I have a
ahead.
question? So perimeter is just basically one side. Area is 2 sides?
No, sort of. Okay, perimeter is all the sides added up, but
Okay.
they are added.
Okay.
Area multiplies length times width. Okay, and I'll help you.
Okay.
I'll help you. Perimeter is adding the sides, so we're just dealing with adding sides. That's why perimeter is 1 dimensional. But when we start to multiply, we multiplied 2 numbers to get area. Multiplied gives us 2 dimensional. Sort of. Let's do a problem.
I still remember how to do it.
Always, it always helped me in all of my classes to get these notes down and then show me what you're talking about. So let's find a problem and actually work one off of your worksheets, and I think it will start to make it a little clearer. Let's go to page 3. It says scale factors area. Looks like this. Scale factors area. If you're numbering your pages, it's packet 4, page 3. And I'm going to do number 1. Number 1. So, and this is R. And they said, this is 30 inches. And the area of this, we don't know. And then they have a little one. And it's Q. And this is 15 inches. And they say the area of this figure right here is 88 inches squared. Notice that whenever you give the answer to area, it's squared. This will remind you, okay? So looking at just the figures, these are just straight lines, these that they gave us. So the scale factor, for some reason, the spelling does not look right today. From R to Q is the same as we've always done because that's a straight line. That's a straight line. So from R to Q is 30 to 15, right? Which, if we go ahead and simplify that, it's 2 to 1. So the simplified scale factor from R to Q is 2 to 1. Are y'all okay with how I did that? I divided both of these numbers by 15. It's like reducing this fraction. I divided by 15, and got 2 over 1. Okay, that's what I was doing here. So we're going to set up a proportion using the scale factor that we know. Okay, we know 2 to 1 because we're putting the R. Is this going to be in a bad place? Okay, 2 to 1. Yes, because this is the, oh, that's what I was doing. R to Q. Okay, 2 to 1, right? But they're wanting us, let's go ahead and set it up for the area. So what's the area of R?
It is 30. Of
The area,
Yeah, the area.
okay?
And
And what's the area of Q?
88.
88. Now, right here is the change. We are talking about area here. So our scale factor has to be squared in order to make this come out correctly. So I need this to be squared and this to be squared. I need the scale factor to be squared if I'm going to work with area. So now I have, when I multiply here, I have 4 times 88. So I have 352. Is that right, y'all with calculators?
Yeah.
352 is equal to 1 squared is 1 x. Believe it or not, we don't have to divide because x is by itself already. So the answer for the area of this figure equals 352 inches squared because it's area. Now look on the back and make sure I did it right. I don't want to teach some more
Yes.
if it's not, if the answer's not correct.
Yes.
Oh, yay. Okay. I was pretty sure it's been a while since I've done it. I want you to take it in. Take it in. Questions? Questions?
It's not yet.
So when we're comparing just straight lines or perimeter, our scale factor is just our scale factor. When we're comparing area, which is what we were trying to find in our problem, we need to square our scale factor before we do our cross multiply because they're asking area compared to area. And I think this is one of those things that you understand, you see it, but when you start to work it, you may have some questions. But I think the only way to get this in your brain is to plow into it. Let's look on the next page and see if there is something different on the next page. Not really. They're going to mix up perimeter and areas. They're going to mix them up on the next ones. Okay, let's just look at the next 3 pages. The next 3 pages in that worksheet. I want you to try to do those. This page that we just worked right here. The next page looks like this. So it's going to ask you questions about the perimeter or area scale factors. Okay, that will just take some thinking. And then the 3rd page is a chart. And they're going to say, when it says ratio here, that's the same as scale factor. Right here, y'all. Where it says ratio up here, it's the same as scale factor. The ratio of the perimeters, and then find the perimeter of Q. This is going to take some looking at your notes and just practicing and asking questions. So probably Tomorrow, we'll do some more of this. We'll continue on with this, but work really hard at trying to think here, okay, as you work these next 3 worksheets, knowing what you know, ask questions, and then mark the ones that you're having a terrible time with. And then we'll work those tomorrow. Is everybody okay with that?
Yes.
Are
Yes,
there any questions so far?
no.
Okay. Climb into these next 3 worksheets. That would be page 3, 4, and 5 in that worksheet or the work packet 4. And we'll come back tomorrow.
Okay.
You feel okay to tackle it?
Oh yeah.
All right. You know I love y'all.
I love you too.
And yesterday I found out some people like to stay on and ask questions. That's perfectly fine with me. Okay. Stay on as long as you want. I'll go ahead and do other things. And then as soon as you have a question, you ask me. Or if you're ready to go, that's fine too.